Okay, we left off. We just have a couple more example problems. They say some problems from calculus, which is great because this is pre-calculus. Just tying in basically inverse functions now with like expressions, okay? With something like 3x instead of just taking the inverse cosine of like 2/3, like a numerical value, I have an expression. Okay, we can do this the same way though. So remember these composition ones. And when I'm saying composition, it's like I'm taking the sine of something else, like f of g of x. And my inside function is inverse. And then my outside function, I'm going to take the sine of it. So our cosine, inverse cosine, of 3x will give us some angle. So again, for inverse cosine, my output has to be in between 0 and pi. Now, for sake of this problem, we don't know what x is. It could be a positive value. It could be a negative value. So we're just going to draw this triangle quadrant 1. We're not actually going to solve for x. We're just writing an equivalent expression to like taking the sine of this angle. So again, for sake, it doesn't really matter where you draw this angle. We're just going to draw a nice angle here in quadrant 1. We're going to call it theta. And what we know is that the cosine of this angle is 3x. Okay, that's what that's telling us here. It's telling us that the cosine of some angle is 3x. Okay, and we're trying to figure out what that angle is. That's what inverse function is. Now again, we're not actually going to find this angle. We just have to take the sine of it. So cosine is adjacent over hypotenuse. So if I just have 3x, we can think of it as 3x over 1. Adjacent here would be 3x. The hypotenuse would be 1. Okay. So basically what I want to do is I want to take the sine of that angle. Okay, because like I said, we're calling this, this angle here, theta, some angle. I want to take the sine of that angle. So for sine, I need to know the opposite side, which that's unknown here, over the hypotenuse of 1. How could we find that unknown side? Pythag, yeah, right triangle. Let's do Pythag. Okay, I'm going to call this, I just called it y for now. And that's convenient too, because usually that is like our y coordinate. So let's do Pythag here. 3x squared, my 2 legs squared, equals my hypotenuse squared, which my hypotenuse is 1, so that's pretty nice. Okay, so I'm going to solve this then for y. So 3x squared is 9x squared. Normally we would need plus or minus, but again, we're kind of just assuming right now we're in quadrant 1. We know that can change with x, but you don't really need the plus or minus just for sake of this problem here. Let me label this then. Okay, let's just move this over quick. Oh. Okay, so this side in terms of x is the square root of 1 minus x squared. Now, we do a lot of like this stuff in calculus where we have to get everything like in terms of one variable. So these problems like called like related rates, where you have to find like a way to relate variables. And this way, the way we related it was by Pythag, so we can write everything in terms of one variable. That's why they're called some problems from calculus. Not that you'll do like this exact inverse sine problem, but we do a lot of this like manipulating of equations to kind of get everything in one variable. Okay, so all we have to do, ooh, this one was a good one. Oops. Is we just have to write an algebraic expression that's equivalent to the sine of this angle. Oh no, these are really expensive.
Can I see it?
My green one's broken too. Ooh. Remember how the green one wasn't working? Today it is. Alright, so sine would be opposite.
That's pretty bad.
Over hypotenuse, which is just 1. Look at this one.
I thought this was with the calculator.
No.
Oh no, that said calculus, not calculator.
Yeah, Goozy.
Oh my gosh, that's funny. Okay. So there would be an equivalent expression. Algebraic. Again, we're not doing any like solving. We're not actually even finding the angle or anything.
My green one doesn't go there.
It don't matter. Thank you.
These are fun.
Okay, so maybe
Oh,
walk
now
you.
I have to catch up.
We're gonna do one more. I'll kind of talk through it again. We knew that cosine of some angle is 3x. So I just drew a right triangle and labeled that. Again, we're not quite sure what quadrant it's in, but because we don't know what x is, but you can just, for sake of finding an equivalent one for sine, just draw it here in quadrant 1. We knew cosine adjacent over hypotenuse. Precalc was a way to relate these variables, if you will. Solve for y, and then I just had to take the sine of that angle because that was like my outside function here. I want to take the sine of that angle. Okay, let's try one more. There's only like 1 or 2, I think, of these in your homework. Are you good on that one, Ashton?
Yeah.
Okay. This time, my arctangent or my inverse tangent is 1 over x. Or another way to think of that is the tangent of some angle is 1 over x. Again, we don't have to solve for x. We don't have to find that angle exactly. Usually we would have to, but in this type of situation, we're just writing an expression here. So, again, we'll draw one in quadrant 1. Sum theta. And let's label what we're given. Tangent is 1 over x. Tangent's opposite over adjacent. And I need to find the cotangent of that angle. Do I even really need to find the hypotenuse here to find cotangent? No. It would just be the reciprocal. Yeah, it's actually just x in this case.
Gosh, diggity darn.
You can if you want to. I went through and did the math.
They should all be like that.
Pi thing. You can, but you won't end up using the hypotenuse. Okay,
So,
that's our inverse
that
for
one,
you.
why didn't you put what it needed to be in between? It's like negative pi over 2. And then
So because we don't know like what x is, it could be positive, it could be negative. I'm still thinking that it's gonna be somewhere either in quadrant 1 or quadrant 4. I said quadrant 4 and then I wrote down 4. It's gonna be somewhere in between these 2 quadrants. And I said it doesn't really matter because since we don't know what x is, it could be positive, it could be negative. But for these problems, because x is unknown, you can just set it up in quadrant 1.
Oh no, I get worse.
okay, I guess.
Does that kind of make sense?
Kind of, yeah. Why not?
Okay. Do we have any questions on the inverse? So my best way I can describe it to you guys, obviously it's the opposite of what we were doing before, where I give you an angle and a trig function, for example, the sine of pi over 4, and you would give me that number, that ratio, that output. Now we're going backwards, where I'm going to give you that ratio, that output. I'm going to tell you, take the inverse, go in the opposite direction, tell me which angle would give me that ratio. And then your output is the angle within the restricted range of outputs. Because that's what makes it a function. That's what makes every single possible input ratio match to exactly one angle. One possible answer. Okay? Got it? Inverse trig came up today in my AP Calc class. I can't remember why. And I was like, hey, we're doing this right now in Precalc. How fun. All right, so our last lesson is just applications with right triangles. And I've tied a lot of application problems kind of in. So we've done a lot of these, like angle of depression, angle of elevation. We did that mountain one. Remember that one?
No.
How can you forget?
So we're just going to kind of go through and do a few applications. We're going to keep this pretty short. And that's our last lesson.
Are we going to finish it today?
Probably not.
Rip.
Okay, I think I want to stop this video and do a new one.
It's a good idea.
Okay, I'm gonna
Anything
stop
to
it.
waste the time.
You guys can start working on the world.
Oh, I forgot about that.
Those are harder than